third speaker, the paper was submitted entitled Evaluation of Fast Fiber Rating Systems on Hemp. It's prepared by Mr. Christopher Hurren. He has worked as a textile colorist in industry for 10 years. His main fields of research are in fast fibers, composites, and conductive polymers. He is currently works for Lincoln University as a technical research officer in Australia. Please, Doctor.
Can someone come and set this up?
Computers. Rightio, looks like we're on the way. Rightio, my name's Chris Hurren. This is an evaluation of fast fibre reading systems. What we've done, the aim of this was to quantify some published methods for making retting of fibres. To observe the effect that each of these methods had on fibre fineness, to observe what they did to colour of the hemp fibre, to discover if fast fibre retting methods from kanaf and rami and flax could be translated to hemp, and to analyse the handle that you achieve from these methods. So an overview of the project was we carried out 8 different batch retting methods from several publications. The fibre was then individualised in a Shirley cotton trash analyser. The fineness, colour, softness of handle were measured and the results were analysed. So, methods and materials. To start off with, we got our hemp skin, which is a decorticated bark of the hemp fibre. We stripped the bark off the plant. We got that, we piled it up on the floor, we blended it so that we got good blending of all the plants. Then what we did was we loaded it into a package carrier for a loose stock dye vat, and you'll see that it's we packed it at a 310 gram per litre density so that we had a nice flow of liquor through the machine. This is the machine we used. It's a Thiess Eco Block. We run a 10.25 to 1 liquor ratio, and these are the recipes that we used. You'll see just briefly. The first recipe has a pre-treatment of hydrochloric acid, redding for an hour, and the redding conditions were all exactly the same for each method. 60 minutes at 100 degrees Celsius. No after rinse on this one, and then the final after treatment of acetic acid. The second recipe used a wetting agent, pre-rinse with a wetting agent, redding with sodium hydroxide and sodium sulphide, an after rinse, and then after acidification with acetic acid. Third recipe was a wetting agent, pre-rinse, sodium hydroxide, metabisulfite, an after rinse, and then after acidification with acetic acid. Fourth one was a pre-rinse with a wetting agent, just straight sodium hydroxide, a rinse, and then an after treatment with acetic acid. Fifth one, no pre-treatment. Sorry about that. Redding with sodium hydroxide, sodium chloride, ethylene diamine, tetraacetic acid, and sodium sulphite. And after rinse and then acidification with acetic acid. The next one was sodium hydroxide and EDTA by itself, rinsing, and then after treatment with acetic. The next one, sodium hydroxide, sodium sulphite, and after rinse, after treatment with acetic acid. And then the last one's oxalic acid, sodium hydroxide, a wetting agent, and then after treatment with sodium sodium acetate. You'll see the authors of each of the different methods that we had. What we got was a record mass of fibre, but there was still pectins and so forth contained in the fibre. They had been solubilised, but they hadn't been washed out. So we took that, we dumped it into a bath of water 10 times, replaced the water and dumped it again to remove those, and they dropped out as we did that. Then we took the fibre, we ran it through a Shirley cotton trash analyser after it had been dried and then conditioned and lubricated. You'll see the opening roller of the Shirley trash analyser. It works on a laminar flow system. The trash is dropped out into the front of the machine. Laminar airflow carries the fibres through to the back of the machine. These are a collection of the fibres that we collected. There's 8 different fibre bundles. You'll see there's varying colour in amongst those. And we conditioned that ready for testing. Now the first testing that we did was optical fibre diameter analysis using an Opta 100. Now you'll see that I call it fibre profile cross-section measurements, and I'll show you that in a minute. What we did was we distributed the 2mm snippets onto a slide. We placed that slide into a projection microscope with a digital camera. We measured 4,000 fibres off each slide. We call it fibre width measurements because you'll see that from the SEM shot, scanning electron microscope shot, that the fibres aren't circular in diameter, they tend to be flat and ribbon-like. Then we did colour measurement using a data colour SpectraFlash 600. We measured 10 times and we averaged it. The results were these. This is the initial results, which is the actual retting losses and the chemical costs. Now the chemical costs are in Australian dollars per kilo of finished fibre. So method number 1 showed the best conversion of skins to finished fibre with 33.9%. Method number 1 gave the lowest chemical production costs at 90 cents a kilo. Then looking at colour, the main colour that we used was the yellowness index D1925. You'll see that method number 2 had the lowest yellowness index over the range. Method number 8 showed it had a far poorer colour than what the yellowness index gave. Now the fibre was very greeny in colour and that doesn't tend to show up in yellowness indexes. So you'll see here was plotted the yellowness indexes. Number 9 is the a cotton standard. We tried to compare this to cotton and you'll see the cotton is far whiter than the hemp. So you can see that the other samples are far dirtier than the cotton. Fibre width variation. Now this is the micron width of the fibre and the CV of micron width of the fibre. Once again, number 2 exhibited the finest separation of fibres after retting and opening. It also showed the best coefficient of variation, which is a very important parameter in spinning. And you'll see we've plotted those so that you can see it a little bit clearer. So method number 2 exhibited the best results in fibre fineness and separation. We then did some handle testing. Position was we lined them all up in a row. We got some students to line them all up in a row with regards to softness to harshness, and we gave them a number from that. And then we got them to rank them with a subjective method. You see method number 7 had the softest handle. Of course the cotton was the softest of all. Methods 2, 3, 4 and 7, you'll see the 2 to 3 ranking that they've been given means that they all had a very similar handle. And compared to the cotton sample, the hemp was harsher, which is not unusual for chemically retted hemp. It tends to have a far harsher handle than cotton. Conclusions. Method number 2 produced the best fibre fineness and softness of handle and colour. But it had very, very large chemical costs, about $6 to $7 a kilo. And when you consider the fibre's worth about $1 a kilo, not really an effective method. And the chemical contamination loading in the effluent was huge. Method number 1 had good all-round properties, had a fairly low chemical cost, moderate handle, and we felt that it was probably the best out of the lot. Method number 8 exhibited the poorest results in all the areas, and it come from flax, and we just believed that it didn't translate very well to hemp. Most of the systems did, however, transfer very well to hemp. Fibre fineness, we found to have a very good representation of the other properties of the fibre. So the finer the fibre tended to be, the softer the handle, the cleaner the colour. Fibre length is something that we want to look at in the future, and it was noticed that method number 8 had very short fibre length. And we found the fibre colour was affected by the chemicals used in the retting bar. Just to finish up, since we've done this work, we've done further work. So these are the recent developments we've got at the moment. We've actually developed our own retting system for chemically retting hemp fibre. We've produced a fibre in a cotton-like form with pretty much an identical handle to cotton, or the softness of cotton, but with hemp's own little properties. We've processed this fibre in hemp cotton blends, 50-50 and 75% hemp and so forth, and 100% hemp on both open end and ring spinning equipment normally used for cotton. So that's it, and we'll take questions at the end of the thing.
Thank you. Thank you very much, Mr. Hurren.